what I want to do is have a look at this previous problem, but use the other formula. Okay? Yeah. So, this problem, which with the powers of the internet I can copy and then paste onto this new slide. I want to do using that other formula. 1 over the total resistance equals 1 over the first resistance plus 1 over the second resistance. We need to be able to do this because it also, not only does it show us what to do about this 1 over, or the inverse as it's called, but also if you've got more than two resistors in parallel, then you have to rely on this formula, not the other one. Yep.
So it's like another method.
Yeah. Of finding the same one we just done. Yeah, another form. Do you remember us talking about that formula actually being the same as this one? So we're now going to prove that. Okay. So just a little bit of information for you. This 1 over something is often written as the inverse. So the inverse of R is 1 over R, literally 1 divided by it. To invert something is to spin it upside down. And although it's not obvious, 4 is actually a fraction. It's 4 whole ones. And so we could think of this as 4 over 1, 4 whole ones. So if I want to invert 4 over 1, find the inverse, that's 1 over 4. So to find the inverse of something is literally to flip it, the fraction upside down. So what's the inverse of 1 over R? R, or R over 1. Okay. What's the inverse of 1 over the total resistance? The total resistance. So to get the total resistance, once we've done this right-hand side, we need to invert it to get the total resistance. That's the thing, that's the step that people often leave out because the left-hand side is not the subject directly. Okay? So, what I also want to do is to focus on using the calculator to just do this in one hit. So, let's have a look how we do that. If you look at this inversing idea, that you've got an inverse button on your calculator, and if you look at it, it probably says x to the minus 1, because when we come to do the laws of indices, you may know already, x to the minus 1 means 1 over x, or the inverse. Your calculator might say 1 over x. So, but you have a button like that on your calculator. So that will allow you to find the inverse of a number. So to do this calculation, we take our 13.88, which is the first one. So the calculator process is to go 13.88 and then press the x to the minus 1 button. And you'll see come up on the screen 13.88 to the minus 1 plus the next one was 126.3, and then again you hit the x to the minus 1 button. So now you're adding the inverse of 13.88 to the inverse of 126.3, which is what you want to do. So that's that, in other words, the right-hand side of this formula. So you hit equals, and you get an answer. But we want the inverse of that answer. So then you hit the x to the minus 1 button again, and you'll see x to the minus 1 of the answer up here, which is what you want. And so then you just hit equals, and you get the answer, which is
1.55.
And so again we can round that as we did on the previous to 12.51 ohms to 4 significant figures. Exactly the same answer as we had on the previous slide. do is, without writing anything down, work out what that total resistance is, please. One hit on the calculator. Don't forget the all clear button. Okay. Comments on that? One more, and then I'm going to give you some work to do. Circle. Apparently it's a sign of madness if you can sketch a perfect circle. I'm quite good at sketching perfect circles. So. Anybody know what the name is for the outside of a circle, all the way around? Circumference? The name for the distance all the way across? Diameter. Distance from the outside to the middle? Radius. That's the radius. Anybody know the formula for the area of a circle? R squared. Circumference of a circle? Pi times the diameter. Good. Formula I expect you to be familiar with. Okay. So given that the diameter is 3.6 centimeters, I want you to just calculate for me the area of that circle. Let's look at it together then. So, formula. So, now when I put the numbers in, I do use the times symbol. 1.8 squared, and that's literally what I'm going to type into the calculator again, okay? So, into the calculator, I hit Shift and then that button for the pi, times 1.8 and then hit the x squared button. And I get equals an answer. Unit, deciliters squared, for significant figures. Is that appropriate for significant figures? Yeah, ignore decimal places. How many significant figures? So in your answer, yeah, so 10, yeah. 10 square centimeters to 2 significant figures. You might say to yourself that you're losing accuracy, but you're not, because there wasn't the accuracy in the first place. Okay? And the fact that you've said that you've rounded it means that whoever looks at this knows it could be anywhere between 9.6 and 10.4, so you've not lost that accuracy. You might be tempted in that case, because you're allowed to go one more, to go 10.2 if you wanted to, but not 4 significant figures. Okay. So looking at page 36 in the textbook, just generally in this textbook you'll find lots of worked examples. That's why I chose this as a textbook to use. So you'll see in the chapter, there's not a hell of a lot of explanation, but that's my job, I suppose. But what there are is lots of worked examples and then exercises to have a go and practice. So that's why I picked it. If we look at this work problem 16 here. In an electrical circuit, the voltage V is given by Ohm's law. I wonder if this will work. Given by Ohm's law, i.e. V equals IR. We know that. No, well, V equals IR. Find correct to 4 significant figures the voltage when I equals 5.36 and R equals 14.76. So there's the formula, and then you put the numbers in, and there's the voltage corrected. And so basically it's showing you what to do. Note this one, area of a hollow coin is cone is given by pi RL, pi times the radius times the length, and then the unit. So it goes through some work problems. We need to worry about things like large and small numbers, but I'm going to come to that event next time. But I want to get you going on some problems. So once you get the textbook, you can have a look at some of these work problems, but the basic idea is to then get to the exercise. So that's what I want to look at now. I'm going to give you a period of time now. I'm going to just zoom in a bit so you can see it clearly. Can you see that at the back? Okay, so lots of them. Note the questions have the answers at the end in square brackets. So all the exercises have the answers there, so you can check you've done it right when you've done it. Okay. There we go. I'll come help each other. The problem is trying to extract information from the question. Make sure the units are okay and stuff like that. So I wanted to have a go at doing some of these. Let me pause this. So in number 6, density is mass over volume. Quite a straightforward formula to use. We just need to know the mass and the volume, and I divide the mass by the volume and get the density. So deceptively straightforward. The problem with this question is that you've been asked to give the density in units of kilograms per cubic meter, which is common. We either use kilograms per cubic meter or we use grams per cubic centimetre. We don't mix the two up and talk about a density in terms of kilograms per cubic centimetre or grams per cubic metre. So we've got mixed units here. We've got this mass in kilograms, but the volume in cubic centimetres. So before I can do this question, I need to do a conversion. And we were just about to discuss how to convert cubic centimetres to cubic metres. So we've got 173 cubic centimetres, and I've got to convert that to cubic metres. Any thoughts? Because there's 100, yeah, same thing that Sabrika said. Here's a cubic metre sketched out, a cubic metre. This is roughly a metre from the shoulder to the tips of my fingers. So imagine what a cubic metre looks like, across, up and depth, okay, a cubic metre, quite a big volume. Now imagine what a cubic centimetre looks like, and the length of your little fingernail isn't far off a centimetre. So imagine a cubic one of them. Quite a lot of those are going to fit into one of these. Okay, how many? 1 million, right. Why 1 million? Well done. Yep, 100, not times 3, 100 to the power of 3. 100 times 100 times 100. 100 lots of 100 lots of 100 in there. So that's 1 million. So there's 1 million cubic centimetres in a cubic metre, not 100. Now the next question is, do I multiply that number by 1 million or divide it by 1 million? Think of the common sense answer. If I multiply that by 1 million, does the answer look right? So it must be divided by 1 million. Okay, so divide that by 1 million. Now that would be, moving the point back 6 places, 1, 2, 3, 173 cubic meters. So that's the number that you'd have to put into your calculator. Next time we'll talk about using the idea of engineering notation and standard form to speed up this process. But for now, you just got to divide by 1 million, shift the point back 6 places, and now you should get the right answer, okay? So that's something to watch for, units. While I've got your attention, are there any more questions on that? While I've got your attention then, question 4. There is something that here we need to talk about. We'll talk about this more in a minute. It's given you a value in engineering notation. So just a quick note on that and then more on it next time. If I want to put in a number like 5 times 10 to the minus 6, which is in engineering notation, the calculator has got a facility to allow us to do that. To enter that into a calculator, I go 5, and then if you look at your calculator, I've got a times 10 to the x button at the bottom. If you've got an older one, it might say EX, or EXP, or EE even. But that's the most likely one. Right down at the bottom of the calculator. So to enter this number, I don't go times 10. I just hit this button, 5 times 10 to the minus 6. And then I've entered that number. Okay. I think you'll get away with hitting just the minus button on the calculator. But if that causes problems, your calculator is asking for another button, which is a minus sign in a bracket somewhere up on the left-hand side. Or you might see it plus minus, that button plus minus. So that allows you then to put the negative sign in and then the 6. So you can do question 4, you need to be able to enter this number, and that's how you do it. Okay? So I'll leave you, we've got about another 10 minutes or so on these questions. I'll leave you to carry on. So let's have a look at these required questions off the website. That's this here. This is what you're looking at. The front part of this, the first part of this, is generic to all of these exercise lists. You're going to get 4 of them, 4 assignments, 4 exercise lists. And the front is the same. It's not necessary to complete all the questions in each exercise. Like that one we're just looking at, you know, you just do as many as you feel as though you need to do. The harder ones tend to be towards the end, so if they're okay, jump to the end ones. I'll indicate every now and then when some are I consider to be extension questions, which means they're not really relevant for this course. You don't need to have done those questions for the assignment, but you might be interested in having a look at them. The bold questions are the key ones. I'm asking you to do those and hand them in, so I can have a look at them and check that you know what you're talking about, and then I'll give you the assignment, because there's been issues in the past about whose work is this of the assignment, you know. So to be able to sign the thing off and be happy it's your work, I need to be happy that you are doing it. So if you're doing these questions and you can demonstrate you understand it, I'll be happy to give you the assignment and you can go away and do it. So there's no reason why you can't, as I was discussing with Elliot, you know, take away these assignment sheets faster than maybe would be on the work scheme, which we'll look at in a second, and then just get the assignments done, you know, if you're feeling confident with your maths, and then I can even start giving you, hand feeding you some of the stuff for the next unit that's coming up. So you can work at your pace with this. Some will work more faster than others. So these are the ones for this. Chapter 37 is the key one, really, because that talks about histograms and frequency curves, which may not be completely familiar to you. Chapter 38 is to do with mean, median, and mode, and finding these averages, which you've probably done some work on already. So that's probably not the main one, this chapter 38. Chapter 37 is going to be the one that takes the effort, which is why I'll put chapter 37 on here, as I said, as a PDF, so you can look at it until you've got your textbook. So if I open it up, you'll see those particular pages in the textbook, chapter 37, which is around about page 350 odd if you've got your textbook here. So it goes through these pages, and then at the end of the exercises, I want you to have a go at number 9 as a required question, I think. Next week we will be going through histograms and stuff like that, but if you want to get ahead of the game, then you can look at that. There's also a histogram PowerPoint, which we're looking at next week. If you want to, again, look ahead at how to plot histograms, you can look at that. Yeah.
Question 9, is that what it's a problem 9 in the book? So we look at, because it looks about 50 questions on around pages.
Yeah, exercise 145, question number 9. Yeah, so not all the questions up to 9, just that one question. So I actually only require 3 questions from you for this, okay? And 2 of those are finding averages, so it's not too arduous a task. All right. So that's for you to have a go at, and you've got the web address, so please do that. We should have done that. Okay, I want to just finish off now by looking at reviewing what we've been doing, and also think about what we're going to do next time. What we learnt today. We've been basically looking at use of formula. That's been the key thing today. Yeah. I suppose I'm expecting you to have it in written on paper, but if you want to do it on a computer, then print that. Yeah.
When does that have to be done by?
Well, next week I'm hoping, because then I can give you the assignment next week. The sooner you hand it in to me, the sooner you get the assignment. So we've been really focusing on formulae and some basics that came out in the drill, but the formulae is the main thing. Using these things, you just spent some time practicing these things. So what have you learnt to do with to do with these formulae, or anything today to do with the maths? So somebody from the front bench, what can you tell me anything that you've learnt today? Okay. Of course, that's the other thing that I should have mentioned, or often underestimated, the use of the calculator. So yeah, some of the symbols, operations is probably a better word on the calculator, yeah, and what they do. And there's more, as you know, as you've seen, you know, that's part of it, learning how those things work. Yeah, thanks for that. Any someone on the middle?
Rounding up and down makes nice and wide.
Right, rounding to an appropriate number of significant figures. We don't tend to quote decimal places. Why not? Pardon? No, there's a better reason than that. There's a real reason why we don't tend to quote decimal places. Yeah, it can move the decimal place. 136.4 centimeters, 1.364 meters. How many significant figures? How many significant figures? How many decimal places? So in other words, the position of the decimal point just depends on the unit. It's really got nothing much to do with the accuracy. It's the significant figures that give us the accuracy. So again, some lectures will talk about rounding to a number of decimal places and stuff, but you know really that actually that's not what's important. It's the number of significant figures that's important, because they're the ones we measure. Okay, yeah, good, thank you. So significant figures rounding to an appropriate number of significant figures for accuracy, you said? Accuracy, yeah. So in other words, just because a calculator gives you hundreds of decimal places, it doesn't mean to say it's more accurate. It's what you put in that gives you the accuracy. Backbench, someone? Something that you can take away from today? can hear the brains whirring, can you? Have a look back at your stuff, what you've been doing. Have you learnt anything? I'm praying and hoping that you've learnt something today. Right, that's what I was hoping. Even if it's only reinforcing something you already knew.
If you add two different places,
Oh, say that again.
if you're adding two fractions.
Okay, yeah. So adding fractions. The denominator must be the same. Yes. 3 good things to come out of today. Okay. Anything further anyone wants to add? Okay. Well, we'll stop there then.